Back in Spiral 1, we talked about composite shapes, and those are shapes that are made up of more than one basic shape. Here we have a composite shape made up of a triangle, a rectangle, and a semicircle. And I'd like you to try to figure out the total area of this weird composite shape. Pause the video and try it. Well, if you'll recall from Spiral 1, the way we tackled this problem was to break the larger shape into its smaller shapes. So here we have a rectangle. That's the simplest one to get the area of the rectangle. Length times width. So 10 times 8, that's 80 centimeters squared. The next one is this triangle. So area of a triangle is base times height divided by 2. The base is 8 centimeters all the way across, but the height we don't know, so we have to figure that out. And the way we did that in Spiral 1 was we used the Pythagorean theorem. So this side squared plus this side squared equals the hypotenuse squared. So as long as you put the hypotenuse in the right spot, you can figure this out. So do some algebra here, we get the height is 3 centimeters. So now we can calculate the area of that triangle. The base is 8, the height is 3. So area is 8 times 3 divided by 2. Ends up being 12 centimeters squared. The last piece is this semicircle. Well, we know the formula for the area of a full circle, it's pi r squared, and this is half of a circle. So we can just divide that by 2. So pi r squared divided by 2 will give us the area of the semicircle. It ends up being 39.3 centimeters squared. So the total area of this entire shape will just be the sum of all these little areas. So we have to add the area of the rectangle plus the area of the triangle plus the area of the semicircle, and we end up with our total area of 131.3 centimeters squared. So this lesson is about surface area of prisms and pyramids. We're going to be using our area formulas like we did in the warm-up, like we did in Spiral 1, except now we're extending the idea of area to include three-dimensional shapes. So three-dimensional shapes have a surface area. So this will be the entire area that's covered on the outside of the three-dimensional shape. So you can write this down if you need to. Surface area is a measure of how much material is required to cover the outside of a 3D shape. So the way I think of it is wrapping paper. When you wrap a present, you're not filling the box with wrapping paper. You're just putting the wrapping paper around the outside of the box. So this is the difference between surface area and volume. Volume would be filling the box with wrapping paper, whereas surface area is wrapping the outside of the box. That's kind of how I distinguish between surface area and volume. Hopefully that makes sense to you, but we're just looking at the outside of the three-dimensional shape, the total area on the outside, on all of the sides. Let's do some examples. So here I have a rectangular prism, and I want to calculate the surface area. So I'm going to walk you through how you can think about this conceptually, and then I'm going to show you kind of a shortcut. So if you look at all the individual faces of this prism, you have a rectangle right here that's an 18 by 13 rectangle. You have the same rectangle on the other side, an 18 by 13 rectangle. So you have two of those. You also have rectangles on the sides of the prism. You have this 18 by 5 rectangle, and you have another one on the other side. So you have two of those rectangles as well. Next, you look at the top and the bottom. So there's a top rectangle that's 5 by 13. And on the bottom, you have a 5 by 13 rectangle as well. So you have two of those rectangles. So to find the entire surface area of this three-dimensional prism, I have to look at each individual face and find each individual area. Then I add up the areas and get my overall surface area. So for each face, it's a simple calculation. They're all rectangles, so it's all length times width. For these, it's 18 times 13. For these, it's 18 times 5. For these, it's 5 times 13. Now that I have all of my areas for each face, I can add them all together to get my surface area. So that is a conceptual understanding of what we're doing here. When we're calculating surface area, we're adding up the areas of each surface, each face of the prism. But I mentioned there's a shortcut, and that shortcut is to look at your formula sheet and find the rectangular prism. Under the surface area column, you'll find this formula. A equals 2, and then in brackets, WH plus LW plus LH. That is essentially what we're doing here, except now we're just plugging values into a formula and doing the calculation that way. When you do the calculation, you end up with the same answer. So going forward, you can just use the formulas that you have on your formula sheet, but I just wanted to show you where the formulas are coming from. It's coming from adding up all the areas of each individual face on your prism. For this example, we'll calculate the surface area of a triangular prism. So find the triangular prism on your formula sheet, and you'll see the surface area formula looks like this. Area is BL plus AH plus BH plus CH. Now you have to be careful when you look at the formula sheet, there's a diagram with labels on it. A, B, C, L, and H. So you need to make sure that those labels are matching up with this diagram in the right way. So B and L, they are perpendicular to each other. They're the base and the length of the base shape of the prism, which is the triangle. So B and L are the perpendicular ones, 4 and 1.5. A and C are the lengths of the other sides of the triangle. So this side and this side. Now in this case, they're the same, and we're told it's 2.5 meters. So A and C are both 2.5. H is the height of the prism, which is 6 meters. So we want to make sure our labels are correct according to the formula sheet. Now we can just plug in our numbers to the formula and solve. So this is getting the surface area using the formula. You could also analyze each individual face. So find the area of this triangle, find the area of the same triangle again. Then you have 3 different rectangles, a 6 by 2.5 rectangle, a 4 by 6 rectangle, and then another 2.5 by 6 rectangle. If you add up the areas of all of those faces, you'll get the same surface area at the end, 60 meters squared. In my last example, I want to look at calculating the surface area of a cylinder. So here I have the radius and the height of the cylinder, and that's all I need. If you look at the formula sheet, you'll see this is the formula for the surface area of a cylinder, 2 pi r squared plus 2 pi r h. So you can just plug in your numbers and solve, but I want to talk about where this is coming from. So pi r squared, where have we seen that before? Well, pi r squared is the area of a circle. In a cylinder, I have 2 circles. So the surface area involves 2 of those. So that's where this 2 comes from. There are 2 circles. Now this part comes from the rest of the cylinder, the sides. If we were to cut the top and the bottom off of this cylinder and take our scissors and cut down the side and then unroll this, it would look like a rectangle. The height of the rectangle would be 20 centimeters, but the length of it would be whatever the circumference of the circle was before we unrolled it. So that's where the 2 pi r comes from. That's the circumference of the circle. So the length of our rectangle is the circumference of the circle multiplied by the height. So this is really just the area of the rectangle that we're left over with when we cut down the side and unroll the cylinder. Anyway, we have the formula for surface area of a cylinder. Plug in your numbers and evaluate. Now, before I leave you with this, I just want to talk a little bit about units. You'll notice I'm using units squared because we're still talking about area. A lot of people get confused because we're talking about three-dimensional shapes, so they want to have centimeters cubed here. But remember, this is not volume. We're not filling the container. We're putting the wrapping paper around the outside. So this is just area. It's centimeters squared still. Well, the gist of this lesson is if you want the surface area, find the formula, plug in your values, and you can just evaluate that way. If you have any troubles, let me know, and I'll do my best to help.